We're going to talk about the word engineering and engineer in our industry, and not so much why is it so important. I will give you where you can look up that thing, but I'm going to explain you how to get there, and you will see here why is this important for us. So let's open with a question. Who here is a programmer? Any programmers? Okay, almost everybody. Cool. Let's kind of before that. Any managers here? Managers? You're gonna hate me, guys, today, but okay, not too much of you guys. Cool. So bear with me. It's gonna be fun. I'm going to define a programmer as somebody who writes code for the benefit of something, right? That can be a Google senior engineer writing some fancy algorithm for something in Google Chrome. That can be, I don't know, a junior developer writing some nice thing for a web page or something like that. Or it can be a kid trying to put his name on an infinite loop on a page, right? So somebody who writes code and get a result. What is an engineer? Engineer is a person who has structure in this. It is not just about getting the result. It's about having standards. It's about having procedures and processes. Actually, there's no better person to tell you about this, because before I was a programmer, I was actually an engineer. I have a master's degree in mechanical engineering, and for years I was really struggling to understand why are these software guys using this word. It's not all right? I was wrong, of course, because after I learned there is actually engineering. There are standards. There are procedures. It's just we are not using them, right? So again, maybe you know about this funny definition of an engineer, right? A person that solves problems you didn't know you had using methods you do not understand. That can be also a programmer, right? But the second part is interesting. A person that has forgotten more about math than you ever knew. Oh, I can testify this part. Oh yes. So story time. I have a friend. He's a mathematical genius. His head is this big, right? Huge brain, and he's really, really good at doing algorithms, complex mathematical stuff. He enjoys that. And then he asked me one day, okay, I would like to try myself in software. I would like to be a programmer. And I was like, okay, here's some tips and tricks, what you need to do. Start here, go there, and report, right? And I will guide you through this, right? In no time, he's calling me saying, oh, I had a job interview. I was like, wait, job interview just started. What's happening? He's like, no, everything was great. HR interview was great. Yeah, he's a smart guy. He can do that really good. Then algorithms and data structures interview was great. Okay, you're a mathematician. That's supposed to be good. And now I got a small task that I need to do at home, and then I need to send it back. And I'm like, great, do you need help? He's like, no, I got this, it's easy, bye. I'm like, oh, all right. In a couple of days, he's calling me saying, I'm so sad, they didn't call me anymore. I was like, okay, can you show me the code? So there is this simple task, really simple task. It was, I believe, in React or something like this. So you need to, there's like a to-do application, right? And he actually, the part regarding algorithm, right, efficiency of the code and everything was actually great. But then I saw a problem. And now, at that point, I understand why is this happening. So what's the problem? You know, in JavaScript, you don't need to, but you can write semicolons at the end of the lines, right? Please do that. He was writing the code in such a fashion, semicolons, no semicolons, semicolons, no semicolons, and so on, right? His indentation was all over the place, blank lines everywhere. Naming is, wow, I needed a lot of time to understand this simple problem and his simple solution, right? That's the purpose of this task. Like anybody can solve it, but not anybody can write it in a way that another person can understand it immediately, right? So that is engineer. Engineer is somebody who use standards, standard procedures, standard way of work, standard workflows that other engineers can easily understand and pick up, right? So you need to be able to write that, and you need to be able to read that also, right? Why is this important? We don't have time for this. This could be a book. But I encourage you to watch this. This is, I think, one of the best stand-up talks I have ever seen. And at the same time, it will tell you exactly why it's important for all of us to be programmers. This is a talk from Uncle Bob Martin. And you will see that I will mention this person a lot in this talk, right? So we are going to concentrate on how, like these standards and disciplines that make us programmers. Yeah? So cut the crap and what exactly, right? Let's go. First thing first, I'm going to go from zero. Like maybe you already been here, but maybe you want to start from scratch. This goes for everyone, right? Pick a programming language. Pick any, they say. But I'm not going to be politically correct today. And I'm not going to say pick any, because I have a strong opinion on this. So watch for it. Can everybody read this? Just in case. I'm going to repeat. Do not choose JavaScript. Just yet. Bear with me. So I would strongly encourage you to choose the harder start, because later it's going to be much easier. I would encourage you to choose a compiled, strictly and strongly typed language, like Java or C#.
I have a question, sorry.
Yep.
What about TypeScript?
Let's go with TypeScript.
I said not yet, right? Don't kill the buzz, man. we'll go there. So I encourage you to go there, because changing from one of these languages to any of these or other languages, it's a long weekend, nothing else, right? But getting there is harder at the beginning. But I still encourage you to do this. Pick your favorite way of learning a language. You can use a Udemy or YouTube tutorial. You can read a nice book. I would recommend you to go with, especially if you're beginner, I would recommend you to go with O'Reilly's book, one of those Head First Java, Head First Python, one of these books. They are really great. But still, if you want to learn a different way, completely fine. You just go through a syntax of a language, right? And then write some code. Play around, have fun. This is the crucial thing. If you don't have fun, this is difficult stuff. You will not get far, right? While you're having fun, it is really important to understand what you need to actually do, right? So while you have fun, practice OOP concept, inheritance, encapsulation, everything OOP, right? Then make simple, small programs. Don't go crazy yet. Make simple, small programs, terminal programs. I don't know, like calculator for this, for that, whatever. Don't do GUIs for now, just for now, right? Next step. At this point, most probably you will use just a text editor. Again, some of you I know still are using text editors. That's all right. But I would strongly encourage you to learn an IDE, one proper IDE for your chosen language, because later you will see for bigger projects, for bigger things, it will just save your life. And it will actually make your work a bit better, right? So I'm not going to tell you which one to use. By the way, use JetBrains and Visual Studio Code. Next step. Now we can choose something that will allow us to build a full stack application, actually. Choose an MVC framework. Every language has at least one great framework, right? But then again, I'm not going to be politically correct. I'm going to tell you exactly what you need to do, right? If you're using Java, at this point, exclusively go with Spring Boot. Nothing else. Later, do whatever you want. Go through the process, but for the purpose of this process, use that. For C#, there's nothing else, but this is good enough, right? For Python, use Django, not Flask, because again, you will learn more here, right? Then you can switch, no problem. Really important for PHP, use. We are talking about PHP, incredible. But I must tell, new PHP is actually kind of good, right? So don't use Laravel. Use it later. Laravel is a great framework, but it hides a lot of stuff from you. So use Symfony. For Ruby, there's Rails, and we don't use JavaScript. Write some code. Get your hands dirty. Again, have fun, right? What to make now? Huh? Make a fully working application. Now you have the tools to actually have something from the database to your GUI, right? And yeah, create a couple of entities, create, I don't know, you have a table in a database, create a row, read from a database, update the row, delete the row, right? And make another application. And at the end, actually deploy it. It doesn't matter. It doesn't need to be perfect. You just need to go through this process, to the basic DevOps, right? You need to know that, right? But don't go crazy with it. Just play around, have fun. That's the most important thing. Okay, this is again a tricky topic. Nowhere, like in 99.9% of the cases, you will never use algorithms and data structures the way you are asked to do on an interview. That doesn't make sense, but it doesn't mean that that is not important. But you need to understand what is important. You need to understand what big O notation is. What does it mean when your code is time efficient or memory efficient? That is actually important. So you need to know that if you have nested for loops, that's bad, right? It's better to have one after the other or some other algorithm, right? But that's all. Then if you want to, if you have a solution and you want to make it better, faster, whatever, you will Google for algorithm, then you will learn the algorithm, then you will implement it, right? Don't go crazy with this. If you are working in embedded systems and I don't know, C or C++, okay, maybe you will work more with this. But where we are going now, you don't need to go crazy with this. Just the basics, right? Write some code, edit your, you will see, oh, my controller is not efficient. I have 3-4 loops here, right? Now there's a chance to play around it to see it, how that plays out. You'll be happy. And congratulations, you are now a junior programmer, right? But watch the word, programmer. And another thing, you are not the king of the world. Because now you know about the database, now you know about GUIs, now you think, oh man, I can build anything, right? Yes, you can, but we are still not there. Watch it. Now the engineer's journey begins, right? We will explain later what does it, where are we actually going, right? So step one in the engineer's journey, right? It's all about clean code, but clean code on so many levels. So let's just cut the crap and go to the point. Read this book, or if you like videos, watch this video series. That's it. This will change your mind. Your brain will explode a couple of times during reading this, right? It will hurt on so many levels because you will learn concepts that at first doesn't make any sense, but later you're thinking, wow, why didn't anybody already tell me about this, right? So what you will learn? You will learn how to name stuff. Classes, functions, variables, sorry. You will learn how to properly write functions. You will learn how to use comments. By the way, don't use comments. You will learn about formatting, error handling, unit tests, test-driven development. Important, right? Like if there's a person who is telling you that test-driven development is not the way, that person doesn't know what test-driven development is, or that person is like 0.01% of the case where that actually doesn't make sense. In all other scenarios, this is what you need as an engineer. You write this for yourself. There are other kinds of tests that you write for others. This you write for yourself. And this is a crucial thing here. Not the only one. Then again, there's a lot to talk about, but I just wanted to point this out, right? And now again, write some code. Now you will see many places where you are instantly going to improve, right? And now immediately you are this. you are now a junior engineer. Now when you write something, senior can understand it, right? Now when senior writes something, you can understand it. Wow, isn't that great? But you are still not the king of the world, right? There's more here, right? So not everybody wants to go direction software architecture. And I'm going to explain you why. Excuse me, can you explain me your architecture in your system? We use Spring Boot, and then we use React on the front end, and then on the back end we have No, that's not architecture. Those are tools, right? Architecture is something like microservices is not an architecture. It's just a way of separately deploying your code, your clean code. Architecture is, the right word is design, software design, right? But people now are splitting these, right? So this word is hijacked and we just need to use design instead. But there is actually only one architecture that you need to know, only one. It's been here for decades. It's a golden standard for last 20 to 30 years, and I still don't get it why people don't use it. I just don't get it. That's it. So this is called hexagonal architecture. Some people call that ports and adapters, plug-in architecture, clean. The name evolved. The thing didn't. This is the only way. So again, in 99.9% of the cases, choose a project, any project. In 99.9% of the cases, this will be the best possible solution. The best possible. And the remaining 0.1%, it will be second best. Why invent a hot water, right? Why is this architecture great? Why is it so good? Because it is allowing us to be framework independent, tool independent, right? Really shortly, we could talk about this for a year, but really short. Like there's this entities thing. That's actually what you persist. Those are your application independent business rules, right? That's the thing you persist. Then you have use cases, right? This is actually where your all application logic lives. And this thing should not use any tool, any framework. It should be only the language that you have chosen. Maybe you could use, let's say, but really carefully, dependency injection container, which needs to be implemented in a way that it can be switched if you want to decide to switch it, but ideally no. Yeah? And now you have the connection to your chosen frameworks. So your frameworks, your tools are a plugin to your architecture. This is architecture. Microservices, Docker, Kubernetes, that's not architecture. This is architecture. And when you split your code this way, then you can cut it and ship it as microservices, right? You can use Docker, you can use whatever, right? But differentiate tools and design architectures, right? So the best place to learn this, and you should go there, of course, is this book. It's a kind of new book. And you can also watch these video series. Now, again, build something bigger. Play around. Build something bigger. Now you can. You have the power to do this, right? But before you are the king of the world, we need to talk about design patterns. So up to this point, you will be pretty good. You will be pretty intuitive. At this point, maybe you are already using design patterns that you don't know that you're using, because your code, your architecture mind is clean and it kind of fits itself, right? But it is a good idea to know that design patterns exist and to know them, like to understand what types of design patterns you have and what are the cases where you might use them. So when you see the case, you might go, okay, I could try with the design pattern. Don't go crazy there, but really important to know. There's this, of course, design patterns book from 1995. No, it is not old. It is actually still up to date. It will always be up to date. But it is a bit hard, right? So maybe you can have that book as a reference, right? But if you really want to learn design patterns, you should start somewhere that's not so, it's really not easy to understand, right? And now again, write some code, play around. I expect greatness here. Yeah, but now we know that we will never be the king of the world, because now you know that there's this infinite depth of knowledge all around you, right? But here's the point. From this point on, you don't learn the engineering, the programming. You just learn tools. You just plug and play your tools, right? It's easy to switch. There's a but. Don't be sad. This is but for don't be sad, right? Because now you can write JavaScript. JavaScript is so crazily bad language. It's so free. You can do anything with it, and that's dangerous, because if you don't know how to use it, you will kill somebody, right? So now when you know all of this, when you know how to structure your code, how to architect your code, how to structure your components, now you can use any language, and that can be also JavaScript. By the way, don't use JavaScript, use TypeScript. Next step, Agile. Oh boy, I could talk about this. I could not talk, I could rant about this one. Scrum Master. Any Scrum Masters here? Thank God. Because Scrum Masters, Scrum PhDs and stuff, that's wrong. That's Agile being hijacked from engineers. Agile is created by engineers, by the best of them in the world. For engineers, for us. And then managers came and took it from us, right? So managers don't know what Agile is. Managers don't know what principles of Agile mean. Principles of Agile, so I will name some. Test-driven development, clean design, simple design, right? Pair programming, refactoring. No manager can understand these concepts, except if the manager was an engineer before, right? And these are crucial. So we have a problem here with this Scrum certification stuff. So I want you to not learn, just take Agile from the people who have created it, the original Agile, right? This is the newest book. It's not yet available in Germany, right? But there's this video series, and there is the original Kent Beck's Extreme Programming. So Agile is just like a user manual for an engineer. I don't need to go to a weekend course to learn how to use my TV. I just read the manual and use it. That's it. That's Agile for an engineer. For an engineer, it's easy to go take a process, learn it, do it, right? Yes, now we are engineers. That was our goal, right? Again, there's still stuff to learn if you want. But I would say that this part is mandatory. We all should do this for ourselves, and also we should teach newcomers, new programmers, students, this path. That's the only way that our industry can actually survive. Do you know that we double each 5 years? That means that each 5 years, every 5 years, there's a huge number of us, half of us, that have less than 5 years of experience. There's no way you can learn this on your own, right? So embrace it, take it, you will not regret it. If you're an employer, train your people like this. If you're a CTO, better know this. If you know this, make your team know this. It's the best return of investment ever. I'm doing this for the last 3 years. I started from myself, and I'm doing this to juniors and to students with amazing success. I can only recommend this. If you want to go further, there are a couple of more topics for you. Learn more about TDD, again from people who have created it, right? So this book is by the person who have created test-driven development, right? And he wrote the book in late 90s, I believe, right? He was using test-driven development for 10 years before he published the book. Nobody knew about it, right? And you think, oh, that is an old book. You know, we have new problems with mocking and this and that. No, this guy was using this for 10 years. All of your problems are in this old book. So I strongly recommend it. Or if you like videos, that's basically the same thing. This is an awesome book. On refactoring, if you want to go deep, excellent book by legendary Fowler, like awesome book. If you want to learn and think more direction architecture, this is the book for you. And if you are working with legacy code, the golden standard. You cannot go wrong with this. I am 6 minutes over, right? Thank you.